The European Council for Nuclear Research, renowned for its contributions to nuclear research, stands at the forefront of scientific innovation. A unique discovery, made by the famous particle physics laboratory CERN, was recently announced to the public. According to scientists, this surprising finding, obtained from the Large Hadron Collider, could change our perspective on the universe. Experts are excited and discussing the fantastic idea that this intriguing discovery may prove that extraterrestrial beings inhabit the same universe. Will this extraordinary event alter our perception of the universe? If so, how is this understanding emerging? Let's explore how CERN researchers are breaking down the taboos surrounding a finding that could fundamentally change our worldview and delve into this new discovery. Founded in the mid-1950s, CERN is known for conducting extensive experiments. Despite garnering significant interest, its experiments have led to concerns about the potential to split reality, create black holes, and cause other problems. The construction of the Large Hadron Collider is one of CERN's most ambitious and controversial endeavors. This collider, the latest iteration of the current CERN accelerator complex, which began operating on September 10, 2008, features a series of accelerators that increase the energy of particles and superconducting magnets over 27 kilometers long. Over $4.5 billion was spent on this incredible creation by CERN. Many believe this money was wisely spent, thanks to the LHC producing some of the most significant discoveries of the past few decades, including the discovery of the Higgs boson and other previously undiscovered particles. This massive machine has the ability to spin various particles around the ring at 11,000 revolutions per second, and at speeds approaching the speed of light. This is accomplished by the Large Hadron Collider using very powerful electrons in an accelerator that produces a magnetic field 1,000 times stronger than that of an ordinary magnet. Concerns have been raised about how strong magnetic fields might affect nearby electrical equipment and the Earth's magnetic field. When two objects are forced to collide, a great deal of energy and power is released. The colliding objects scatter in all directions, and most are quickly annihilated immediately after the collision. Researchers can find new objects by moving the position of an object. With this idea, special high-security devices are placed around the crash site to collect data on each event. This amount of data can increase rapidly and is labor-intensive and time-consuming to process. Each year, these collisions generate approximately 15 petabytes of raw data from LHC experiments needed for basic data analysis. The library has over 200 petabytes of data. 1 petabyte is equivalent to 250,000 movies. As scientists have indicated, they have found evidence for the existence of quarks, the fundamental building blocks of matter, which come in various colors. Some of these quark varieties, due to their instability and immense density, transform into other things. Beauty quarks, with lifespans of 1 trillionth and 2 trillionths of a second, are the focus of attention. Based on conventional assumptions, experts predicted a different decay trend. However, quarks have only a 70% chance of decaying into muons if they decay into electrons. According to data from the Large Hadron Collider, these variations are only possible if the processes in question have an unknown origin. Some experts have concluded that this suggests a new application of physics may be involved, and that a whole new physics could be revealed by a new force-carrying particle that could expand the standard model and provide fascinating new insights. Model theory offers us the best explanation of how the universe works. Even with the possibility of new physics, the scientific foundation that explains everything we know about the properties of the physical universe is the standard model. Surprisingly, physicists are aware that the model is not yet complete, despite its high degree of accuracy. The standard model currently only explains 3 fundamental forces: the electromagnetic force, the strong force, and the weak force. As of now, there is no explanation for either dark matter or gravity. Given the data collected by the LHC, it is not uncommon to find findings outside this framework, but this time, it has attracted the attention of experts who believe further investigation is needed to create this unique scenario. Could the surprising discovery be explained by this new force? Scientists have hypothesized the existence of a brand new energy source, an energy carrier they call the Z boson. Scientists believe that although this force appears weak and has not yet been detected, it interacts with electrons and muons. While it remains a mystery where this fits into the Standard Model, if confirmed, physicists believe the discovery will contribute to explaining long-standing puzzles about the universe, including the nature of dark matter and the function of the Higgs boson. Unifying the fundamental forces of life is one of physics' most important goals of the past century, and some scientists believe this unknown energy could help achieve it. The European Organization for Scientific Research, led by Elon Musk, claims to have built the largest and most powerful particle collider in human history, the Large Hadron Collider, between 1998 and 2008. Hundreds of institutions, laboratories, and over 10,000 researchers are contributing to this endeavor. It is located near Geneva, on the French-Swiss border, in a 27-kilometer-long tunnel about 175 meters underground. Not only that, the LHC measured 3.5 tera-electron volts of energy from the first collision, which is about 4 times higher than the previous world record. The beam energy was increased to 6.5 TeV when the LHC was built. Musk also talked about how well proton beams collide in the Large Hadron Collider. They collide for an average of 1 month per year, especially protons and lead. For scientists, the primary purpose of the LHC is to test the predictions of various physics theories. A broad class of particles predicted by subatomic particle theory are hadrons, subatomic particles composed of quarks and held together by the strong force, similar to how the electromagnetic force holds atoms and molecules together. 2 of these are protons and neutrons. Among these are also muons, first discovered during cosmic ray tests in the late 1940s and early 1950s. 2 different streams of matter are brought together and collided in the Large Hadron Collider. The Higgs field and the Higgs boson are considered the most important particles. Just as waves are seen in water, this field is excited quantumly. From a particle quality perspective, bosons are a completely new species. They lack the carriers of quantum interactions, such as the weak force, the electromagnetic force, and nuclear interaction, and the quantum energy of fundamental matter. At the Large Hadron Collider, 2 large space experiments called ATLAS and CMS simultaneously made an important discovery: the existence of the Higgs boson. The announcement was published by CERN on July 4, 2012. At that time, the new scalar boson was found in 2 rare decay channels, showing essentially pure decay, that is, decay to 2 photons requiring a purely virtual process, and decay to a direct decay. Although the Standard Model was established during the discovery of the Higgs boson, research on the invisible boson has continued since 2012. One of the most important findings is the confirmation of Higgs decay when the 3rd cycle of the Large Hadron Collider begins in 2029. CERN predicted at the time that research on the invisible would intensify, especially after the completion of the high luminosity upgrade of the particle accelerator. This will allow the LHC to perform more collisions and give researchers a chance to study strange physical events beyond the Standard Model. After upgrading the accelerator, CERN estimates that 15 million of these objects will be produced annually. In contrast, 3 million Higgs bosons were created in 2017 by the Large Hadron Collider. Particle physics theory predicts 5 more types of Higgs bosons beyond the Standard Model, some of which have lower production rates than the first Higgs boson. How big is the mass of the Higgs boson? The Higgs field plays a crucial role in the early stages of Earth's formation. It determines the properties of the void that covers our space-time. It is responsible for the production of mass at all fundamental levels we know, and for the existence of matter and interactions. Without the Higgs field and the Higgs boson, atomic elements, stars, and life as we know it would not exist in the universe. What makes you believe that the God particle is the Higgs boson? The phrase God particle comes from Nobel Prize-winning scientist Leon Lederman, who called the Higgs boson the goddamn particle because of the extreme difficulty of detecting it. The word gained popularity when the Higgs boson was discovered. This is the beginning of the puzzle of matter and religion that still puzzles modern physicists. Lederman wrote a book about the Higgs boson in 1990, and wanted to name it the goddamn particle, but the publisher objected and changed it to the God particle. However, it is impossible to overstate the importance of the Higgs boson and the Higgs field, as only mass exists in this part of nature. This means that no star, planet, or individual can give an explanation of the nickname. They want to know what kind of space we live in for two reasons. First, they are interested in learning how to close this gap. The transmission of non-zero neutral potential energy into space is a distinctive feature of the Higgs field. In fact, this explains every distinction in our world. According to scientists, the existence of unlimited amounts of electrical energy and small amounts of weak energy is thought to be due to the form of potential energy. To achieve this, scientists need to produce Higgs boson pairs to understand how these bosons interact. The fundamental question of how other particles in the universe gain their masses is partly addressed by the Higgs boson. However, its magnitude requires an explanation. Theoretically, a loss of symmetry leads to success and causes failure. The vacuum itself can be affected by quantum fluctuations. Fortunately, this measured period exceeds the known time in the world. However, scientists are still looking for more Higgs-like particles to increase the energy of the Higgs boson and provide the new life needed for the body. All these options support further data research and, if possible, more powerful collisions. Therefore, hundreds of experts around the world are still working on it after 10 years. First produced in 1964, the Higgs boson was found in 2012. This is a result of the massive and unstable nature of the Higgs boson. To produce an object of this size, scientists need to focus a lot of energy into a small box. They need a severe electrical breakdown. The Higgs particle decays in various ways after it is formed, and the background can only detect a small part of it. Scientists have built the largest and most complex objects to explain these things. The Higgs boson signature was then discovered by analyzing hundreds of millions of proton-proton collisions. Will it eventually lead to emission? 3 hypotheses have been put forward by conspiracy theorists about the true purpose of CERN. Some people's first negative perception of CERN is that it is trying to open the gates of hell. Some people believe that humanity will emerge from the final gates of hell thanks to CERN's experiments on subatomic particles moving at the speed of light. However, CERN states that the purpose of developing the solution is to provide a deeper understanding of the problem and its scope. According to Wikipedia, antimatter consists of subatomic particles that work opposite to matter. Proponents of the Big Bang theory argue that since matter formed at the same time as the universe, it should be represented equally with matter, but antimatter is extremely rare. The Mandela effect is a phenomenon in which a large number of people's memories of past events differ from their actual experiences. Conspiracy theorists predict that CERN's particle experiments will distort reality, unleash a powerful Mandela effect, and pull the planet into a parallel dimension. Conspiracy theorists claim that the European Organization for Nuclear Research is where human sacrifice takes place. An online video from 2016 claimed that CERN was home to a cult. Apparently, many hooded people are seen wandering around the CERN facility. According to The Observer, a CERN spokesperson denied the report, saying the incident was a joke. Has the police investigation been concluded since then? Therefore, it is not surprising that on July 5, 2022, when scientists began working on merging online after 3 years of research and correction, this statement will disappoint science fans. But it is clear that CERN has no plans to build a gateway to hell, the future, or another dimension. Travel the world fast. The ability to break down materials at very high energies has opened doors to previously unexplored areas of physics. For almost 10 years, the Advanced Search Experiment Detector at the LHC has yielded surprising results. It was able to identify the first high-energy neutrinos created by particle colliders. High-precision neutrino interaction detection was achieved for 153. This is important for physical applications that will help scientists better understand high neutrino interactions on Earth and how emitting stars burn and turn into strange supernovae. The fusion or explosion of atomic nuclei produces neutrinos. These are produced by natural radioactivity from potassium and bananas. as well as by cosmic rays and radioactive decay in nuclear reactors and particle accelerators worldwide. However, this small, faint object represents the ultimate cosmic monster that rarely causes problems when they are made. About 100 billion neutrinos penetrate every square centimeter of our body every second, but they are so powerful that we cannot hear them. Due to their mysterious properties, and because they were first seen flying from a nuclear reactor in 1956, they were called devils. Scientists have been searching for them ever since,